on the calculator, you can use the inverse norm to do those other problems. And so, for example, if we have some problems like we did the one before, this one right here, for the top 10%, we know it's 0.9. So what we would do is we would go second VARS, number 3, and it was 0.9 was the value we want. So we're going to put that as a decimal, and the mean was 505, and the standard deviation was 110. And by doing that, it's going to give us that score of 645.9, which is what we found when we went backwards doing it this way. Okay, so that's if you need to find, if you don't know the z-score and you have to find the z-score and then work backwards to find x. That's fine using the inverse norm. Let's just do a couple of problems here. It says in 2008 Wimbledon tennis tournament. So the average mean is 115, standard deviation is 6. About what proportion of his first serves would you expect to exceed 120? So we've got 115, we've got 120, and it says what proportion. So you can do this one of two ways. You can say z x minus the mean over the standard deviation. You can find the z-score and do it that way. And then look in your chart. And in the chart, it's approximately, because you have to round, 7967. But because it's to the left, we have to subtract from 1. So it's about 2033. So it means about 20% are faster than 120. Or you can go normal CDF, and your minimum is 120. Your maximum is about 10,000, 115, and 6. And again, second VARS, normal CDF, 120, 10,000, 115, and 6. And you get 0.2023, which is a little off, but we rounded on that other one, so they're going to be off a little bit. Okay? But then you have this one. This is where you want to use that inverse norm. It says that what percent of his serves, no, that's not the one I wanted to do. I wanted to do C. The fastest 20% are going at what speed, so we're going to go to this one. And so we know that the mean is 115 and your standard deviation is 6. So 20% means that 80% is lower. So in the Z chart, we're looking for 0.8. Okay, so find the area and that would give us Z. Okay, and so when we do that, we can find that we get about 0.84 for Z, and then we would take x minus 115 over 6 equals 0.84, and so 5.04 equals x minus 115, so x is about 120.04. Or we can, on our calculators, go second VARS, number 3, and get my inverse norm, 80% or less, so we're going to put 0.8, we're going to put 115, and 6. And I realize you can't see that, so let me move that up a little bit. So second VARS, number 3, 0.8, 115, and 6, and we get 120.05, or 0.04, which is pretty close to what I found in the chart. Okay, this one talks about IQR, so we want the 75% minus 25%. Oh my goodness, I have so many papers here, I can't even function. So IQR is quartile 3 minus quartile 1, which is 75% minus the 25%. And so if you find the 20, you want to find the difference of them. So inverse norm 0.75, 115, and 6, and we're going to subtract inverse norm 0.25, 115, and 6, and that makes it so much easier to do than to do it by hand. Number 3, oops. If I close my parentheses, I can do it right on here. And I get 8.09. In my, when I did it by hand and looked in the chart, I got 8.04, but 8.09. That's the distribution, the IQR distribution of his speeds. Okay? That's all I've got right now. We've got some problems that we're going to do in class, and that's about it, though. That's all we've got for this at this point. And I'm going to do one more video. Actually, I'm going to do one more just with some examples. And there's the bell. And actually, let's just finish on this video. What the heck? Might as well. So this one is just an example. Let's just do one example. What proportion of 3-year-olds are taller than 100 centimeters? If we know that the mean is 94.5 and the standard deviation is 4, and again, I'm going to draw my curve, and my mean is 94.5. We're saying taller than 100. So I'm going to just throw this into the calculator. Normal CDF, 100 is my minimum. My maximum is going to be 10,000 because I'm going to the right. Anytime I go to the right, and then my mean is 94.5. My standard deviation is 4. And I get about 0.846. Okay? What proportion of the females are between 90 and 95? Again, if I draw it, here's 90 and 95. Here's my 90, no, I messed that up. 95, sorry, 94.5 and 90. That's what I meant to do. So forget that I did that. Yep, anyway. I did that on the original notes too. So normal CDF between 94.5 and 4. So remember, normal CDF, minimum, maximum, mean, standard deviation. And when we do that, we're going to get 0.419. We can also find the z-scores and do it that way and subtract them, but we really don't need to do that. And then for what percent, 80% of females are at least how tall? So that means that we're saying 80% all here are here. So we can either look in the chart and find my z-score and work backwards, or we can go inverse norm, 0.8, 94.5, and 4, and we're going to get 97.86, I believe. Let me just get this again, 0.8, 94.5, and 4, and 97.866 approximately, and it's centimeters. And you can see how quickly we can do these using a calculator. All right, so that's all I've got for now, and we have finished chapter 2.